Best way to debrief what the HR diagram is to look at a picture of the HR diagram. And we all made one in class, but I added in a picture along with some labels to our Schoology assignment. So I would strongly recommend just jumping over there to the HR diagram Schoology assignment and screenshotting the graph that you see there and putting that into this location so we can kind of label a few big ideas here. So now that you've got your graph put in, just a few reminders. We are looking at a diagram that plots stars based on luminosity or brightness and temperature measured in Kelvin. So when we look at our scale, this end of the graph is our highest or hottest temperatures. Where over here, this is our coolest temperatures. As far as luminosity or brightness goes, these are our brightest stars up here and our dimmest stars down here. So for example, let's just say this star right here, if I'm looking at its characteristics, would be very bright and very hot. Okay, so I'm reading the graph depending on my star location. So each one of these is looking at an individual star in the universe. And just a reminder, this is not a map of the universe. This is not saying all these stars are close together in proximity in the universe. This is saying this is how many stars in the universe share these characteristics of being both dim and cool. So these are not close together in reality. They're just close together in terms of their characteristics and what they're like as a star. So a couple things we want to label here. First thing we want to look at is this grouping known as red giant. I had you mark that in your lab, but we're going to mark it here as well. Go ahead and circle it and just put a spot where we can record what we know about red giant's temperature and luminosity. So a red giant, again, reading the graph, is one of the brightest stars or highest luminosity stars that we can see in the universe. But in terms of temperature, it is one of our coolest or lowest temperature type of stars. And that is the red giant. That is a stage that a star can be in within its life cycle. The other group we looked at here is white dwarf. White dwarf, again, what we know about its temperature and luminosity. Its temperatures are much warmer than red giant. They're not the hottest it can possibly be, but it's definitely a higher temperature grouping of stars. And in terms of luminosity, again, just reading the graph, it is not a very bright star. It is dim, or rather a low luminosity. The biggest group that we're looking at here is known as the main sequence. And really this entire midsection is the whole main sequence. So I would recommend kind of highlighting it like I did, seeing the two groups plus the main sequence, or circling it up just so you can distinguish what is what here. But with the main sequence, we don't have little groupings so much like we do with red giant and white dwarf. We have a whole range of stars ranging all the way across the graph. And so we want to think about both of those sections and what their characteristics are. So I'm going to start up here in the blue area of the main sequence, noticing that those blue stars are some of the brightest stars that exist. High brightness. I'm going to use luminosity, that's our official term. High luminosity and high temperature. What we want to take note about those stars is their lifespan. You can see I labeled it up on the diagram that you downloaded from the assignment. Those stars have the shortest lifespan. And I like to call those stars the semi-trucks of the universe, because they burn through their energy so fast that they don't get to experience a very long lifespan. Because of their really high temperatures and high luminosity, they have some of the shortest lifespan to exist. They're burning through those fuels extremely quick. like a semi-truck would with its gas. It takes a lot of fuel to get that star going, and that vehicle going, and a lot of fuel to maintain a semi going down the road, just like those stars. Here, our long lifespan section of the diagram is a little bit different. These are very dim stars with cooler temperature. These are low temperature, low luminosity stars. And as you maybe can guess, those stars have the longest lifespan on the diagram. I like to call those stars the Mini Coopers of stars, right? Because we know those Mini Coopers, those tiny little vehicles, they don't need a lot of energy to maintain their motion. They can use their fuel very efficiently and for a long period of time. I can get much farther on a tank of gas with my Mini Cooper because it takes less energy to move that vehicle. Just like here, it takes less energy to maintain this low temperature and low luminosity star. So its lifespan is much longer than that up here of the high temperature and high luminosity stars. So the comparison with the vehicles, semi-truck versus Mini Cooper, that makes my connection to what type of lifespan I'm looking at. So these three stages, white dwarf, main sequence, and red giant, we're going to see those start to pop up in our discussion of star life cycle. And now we already have some background on what's going on with each of those stages and their characteristics.